It's so good to see you. I'm so happy to be here. My name is Antonia, and this is my friend Xavier. And if you've been here since the last talk, you may have already heard a very good talk on Edge. So we're going to give another, maybe less good one also on Edge. But we're going to show you, hopefully, a demo. So you're going to see it in action. We want to start with a little bit of an introduction on edge computing for those who may be uninitiated to it, what it is and how it's used in the industry today. And then we want to talk about a specific project which is called KubeEdge, and we will demo it for you as well. So yeah, let's go. What is edge computing? So according to Gartner's glossary, edge computing is part of a distributed computing topology where information processing is located close to the edge, where things and people produce or consume that information. Okay, so how does that look like in practice? So in the slide, you can see a factory at the bottom, and then you can also see a couple of clouds in the sky. A factory is a place where, among other things, information is produced, or data in this case. And the machinery that produces such data would be things like sensors or actuators or other machinery, right? Now, we refer to these kinds of machines as IIoT devices, where IIoT is the industrial Internet of Things. So traditionally, we would send all of this data up to the cloud for processing. However, this can be quite slow, or it can be really expensive to do, or sometimes it will just be not possible to do at all. So in this case, we introduced this nice additional layer that you see here, which we call the edge. It is between the cloud and the device. And as you can see, there is a couple machines here, maybe some servers. You have to think about these as being physically close to the machines, as being in the same network as these machines. So why would you want to do this now? There are a couple of reasons, actually, and here's four for you. So latency. So maybe your edge device is a self-driving car. You want to make a really quick decision. Sometimes you might not want there to be any latency in case you might die. So the other one that you might care about is bandwidth. So you might have a lot of raw data that your processes are emitting, and you need to pre-process them before you stream them anywhere, right? Then there's autonomy. That's a big one, actually. So in case your factory is somewhere in the mountains or somewhere else where the network is really bad, you don't want things to just not work because you don't have network. So this is pretty important. Then the last one is kind of self-explanatory, but privacy. You don't want to put certain data into the cloud, or also there can be a regulation where you're just not allowed to do it, right? So there are lots of fields where these things and others would make you want to use edge computing. IoT, retail, smart cities, telco, healthcare, space. This is not an exhaustive list. There are new use cases basically being added every day. But what we're interested in right now is how Kubernetes could help us with this.
All right, so we talked about edge computing, and let's see where Kubernetes fits and why we might need it there. So there are a few challenges to edge computing, like running workloads at the edge is different than running workloads in data center or in the cloud. So we might need to scale to thousands of small nodes on devices, which are often scattered across remote locations. Those locations will have bad connectivity, will be resource constrained. Regardless of that, we still need to ensure that these things get patched and updated consistently, just like any other Kubernetes cluster. Hence why we're back to these scale, connectivity, and updates challenges that we need to tackle. And this is where Kubernetes already solved these challenges in traditional IT already. So by being declarative, so you have desired states, and then the system will make it real. It is portable, so you can run the same things whether you're in the cloud or at the edge. And it is automated through the use of reconciliation loops and controllers, so humans don't have to do the work, the machines do it for us. And it is the same operational model, as in we have the same familiar Kubernetes API that we already use in the cloud at the edge. So you can use like GitOps and all these things for our edge scheduling. However, vanilla Kubernetes works on the assumption that stable networking is a given, which is not always the case at the edge. And this is where KubeEdge comes into play. So KubeEdge is a project that was started in 2018 by Huawei in China, with the stated mission to extend Kubernetes at the edge and to IoT devices. So the core features and objectives are to offer a standard Kubernetes API, handle unreliable networking, and management of devices through the concept of device twins, which we'll talk a little bit more in a bit. So here you have the timeline of the evolution of the KubeEdge project, but last year it graduated in October as a CNCF accredited project. And a couple success stories of KubeEdge. Like this one is China when they overhauled 85% of the country for their electronic toll collection system on the highways. So the old system would be a bunch of like highway toll plazas with humans collecting fare from the drivers. So that would be slow and manual. However, it was replaced by these overhead gantries that you can see on screen with like mounted cameras that would perform license plate recognition. And this thing would run on over 100,000 KubeEdge nodes, running 500,000 edge applications. And just to put into perspective, this would generate and process around 300 million data points every day. And it is said to have improved traffic efficiency at toll stations over 10 times. And the other pretty cool one is the first cloud-native edge satellites. So the application for this is to address flood prevention and disaster mitigation. So originally, a flood happens, the area is imaged by the satellites, the data is sent back down to Earth, and a person, will compile a report for that. It's pretty slow, pretty manual labor. And also in mountainous regions, sometimes you would have a cloud cover, so the images would be useless, and the bandwidth would be wasted, which we can't really afford anymore. So in 2021, China launched the first satellites, which was connected via KubeEdge. And this thing would would still embed a small AI model. So when the area is imaged, the AI model will process it and identify the cloud cover, analyze the water level, and determine whether that data is worth transmitting downlink to the ground station. If it is, then there is a more powerful model that will process that data and do the same work, but in an automated way. And it said that disaster response time were reduced from days to hours, and the data transmission was reduced by around 90%. So this is quite a significant success story. If you want to see more of these, there's this website, like the public one, case studies. You can check out, there's a lot more, but these two are the main ones. And now we're going to move on to architecture.
Okay, so enough about satellites. This is the fun part where I get to show you a bunch of diagrams. Before I'm going to go into any sort of detail, I want to give a little bit of a higher level overview of what KubeEdge would look like on your cluster. So you might recognize this cloud edge device trifecta here from the earlier slide. And if you look at the cloud layer, you have to think of this as not being in a cloud provider necessarily, but this could be on premises as well. It basically could be any Kubernetes cluster. And on the cloud layer, you can see a component that is called the cloud core. And this is the entry point from the Kubernetes API into the edge. So basically all of the communication would go through this cloud core. And then on the edge layer, you see an edge core. This edge core runs on every edge node. So you see one here. However, there can be thousands of them. And again, this could be toll stations or satellites or something like that. The edge nodes join your Kubernetes cluster by connecting to the cloud core, and they actually show up as normal Kubernetes nodes. They do have a special label on them, so you can schedule your workloads accordingly. And the edge core is installed on your machine as a single binary. So the edge core talks to the device layer via MQTT, and it also talks to local applications, APIs, and so on via HTTP. Then on the device layers where you find the actual devices, so sensors, robots, cameras, what have you. And KubeEdge offers also a framework which allows you to represent these as Kubernetes custom resources. As a side note, you can see that I marked the Kubernetes API related streams here in blue and then the ones related to devices in red. So maybe it's going to make the slides easier to follow. I don't know. Let's talk about the Cloud Core first. So the Cloud Core is installed in your cluster as a Helm chart. And you can use an upstream CLI tool that is called KeyADM for that. You can also do some other fun things with KeyADM. The Cloud Core has a couple of components. The first one you can see here is the Cloud Hub, which is the messaging broker of the Cloud Core. So this is opening a secure persistent channel to each of the edge hubs, and it does that via WebSocket or even quick protocols. The red and blue controllers you can see do two different things. So the first one is the edge controller, which propagates changes to workloads running at the edge from the Kubernetes API to the edge. And in the opposite direction, it will report back things like statuses and events and so on. And then the device controller reconciles the device CRs. So this syncs between Kubernetes custom resource and any managed devices you might have. And actually bundling all of the communication in KubeEdge through this Cloud Core has a couple of benefits. So the first one you get is load reduction. This is done by aggregating updates, so you don't actually send all of the updates from all the 100,000 nodes or whatever. You will aggregate them so as not to overload your Kubernetes API server that much. Then you also get resilience across flaky networks, which is done by incremental updates. So as I mentioned, some of your nodes might disconnect sometimes for a while, and then when they reconnect, you don't actually, again, flood the Kubernetes API server with all these updates, but instead there's like an incremental update process that happens. So you can integrate Edge into any Kubernetes cluster theoretically using this mechanism, and it has been shown that 100,000 nodes were added like that. Now the Edge core, this one has a memory footprint of around 70 megabytes. And the Edge core also has an Edge hub. So this is, as you might think, the counterpart to the Cloud Hub. On the other side, it links to the cloud. It connects via WebSocket or Quick, and it will route the messages from the cloud to the correct Edge modules. It also reports back the node and device status, and it handles things like keep alive and routing messages also within the Edge core. There are two important modules that you can see here as well, which both work with the local state. So the first one is the Meta Manager, which is a cache and message processor. This means that it will store data like pod state, config map contents, and so on in this local database, which is SQLite database. And this is so that in case your node disconnects, it will still work, basically. The other one you can see is the device twin, which keeps track of the state of your devices. So it manages the attributes and status. And it will sync that information to applications that run locally, but it will also sync it to the cloud. Then on the lower left there, you have the thing called HD. And you can think about HD as being the kubelet of the Edge core. So this will manage the lifecycle of pods, and it will talk to the container runtime. You can run workloads on the Edge nodes just as you would in the cloud, and it will also actually handle some other resources that are cached locally, like config maps and secrets and so on. Also, all of the communication that happens within the Edge node goes through this common messaging protocol, which is called Beehive, which is something that is original to KubeEdge. you get 2 buses on top of those. The event bus integrates with MQTT, and then you also have the service bus, which provides HTTP communication. Now, you can also see in this picture the container runtime, which I already said is running workloads under the control of HD. I always have to remember. Then you get the mappers, which we will actually talk about the mappers a little bit later, but they basically translate between device protocols and KubeEdge, basically MQTT. And all of these components here together, there's quite a lot of them, they will allow nodes to keep running workloads, managing devices, doing all these things, whether they are currently connected or not. So let's talk about devices a little bit more.
Yeah, so at this point we have an edge node which is joined to our Kubernetes cluster. This is already a very valid use case because we can schedule workloads on this thing, we can connect it to Flux, GitOps, all that. But we can go a bit further by leveraging the IoT capabilities of KubeEdge. And this is where we get back into the IoT territory. And over there, it's all about protocols. So I'm talking about communication protocols. These standardize how data is collected, transmitted, and exposed in our environment. So an IoT device is just a thing that generates data. So they will be from various sources like cameras, sensors, and such. And they will be exposed on one of these protocols, for instance. There are quite a few more than that. But think like an IKEA temperature that you connect to a home assistant via Zigbee. This is kind of the same idea, except here we want that data to be consumed by KubeEdge. So this is where mappers come into play. So these mappers are translators between the physical world and the KubeEdge world. And in the industry, we usually refer to them as adapters, like HiveMQ Edge. That's what they call it. That's what they call them. Sorry. However, KubeEdge calls them mappers because they map a protocol to something that KubeEdge would likely understand. And we can visualize this a bit more clearly on screen here. On the right-hand side, we have the hardware devices that generate set data. On the left-hand side, we have KubeEdge, and in the middle, we have these mappers. So these are containers running on our edge nodes. They have like this Zigbee dongle, for instance. They know how to talk to these things, and then they will convey the data back to KubeEdge via the messaging protocol. There are already a few mappers upstream that you can leverage, like these ones, I think, already available. But there is a framework to build your own in Go. And once we have these mappers running, we need to get these hardware devices into KubeEdge. So there are a bunch of custom resource definitions that we install with the Helm chart. But the two main ones that we want to talk about here are the device models and the device instance. So the device model is the type of hardware device, and the instance is the thing that we will deploy in our environment. And here we have a slightly simple example here with the Advantech LM6017. I've never seen or even touched one of these. I just Googled it. It seems pretty simple. So it has 8 channels to which you connect sensors, Modbus register address for each of these, compatible Ethernet, so you can access it on IP and port. And just for the sake of showing you what it looks like, so on the left-hand side, we have the custom resource of that device model. So we have a channel, we have a property for each of these channels. So we would have 8 of these, only 2 on screen because we have limited space, and a protocol which is Modbus, in case we have a mapper with the protocol Modbus registered in our edge core. And yeah, that thing on the right is just an extract from the user guide where you would find the Modbus addresses for each of these channels. And then in our device instance, we get pretty much the same things. We have a device model ref that references the device model we just created, config data on how to access this thing on IP and ports, and then on the right-hand side, we specify the Modbus register addresses. You can add like push methods if you want to push the data to like an IoT platform or something like that. But enough theory, let's get into the fun parts, which might be not so fun part for us, but let's cross fingers. I'm just going to move this thing. So the demo here is, there's a picture of me raising my hands here. this is just to give you an idea of what the app is actually doing behind the scenes, because we run this thing in a container, so there's no visual feedback. But we have a camera here, which is connected via USB to this wonderful Raspberry Pi. This Raspberry Pi runs KubeEdge, and it's connected to a Kine cluster on my laptop via this Ethernet cable here. It's quite a bit to set up when we do a talk. And this Python app that we run on this Raspberry Pi runs the Google Media Pipe framework, which allows you to use like OpenCV to detect like human postures. So here we extrapolate a shoulder line, like with like your like limb parts or whatever it's called. And when a hand is detected above the shoulder line, it will be considered as raised. So you can see there are 2 raised hands. So the slight limitation on this thing is that there is 1 shoulder line, and there are many shoulders here in this room, so we can only work with, say, the front row here. So you guys are gonna have to play ball, I'm sorry. But first, I'm going to install this thing, because for some reason I decided to install the mapper and stuff during the demo. Where am I? Okay, I might need to zoom in a bit. So here we can take a look at our cluster. So I don't know if it's big enough. So you can see that we have the control plane node, which is our Kine node, and then we have the Raspberry Pi. If we describe the Raspberry Pi, you can see that it's just a normal, regular Kubernetes node with like labels, request limits, all these things. So the label will be what you would use to schedule workloads, like Antonia said. And if I look at the pods currently running, you can see, well, there's quite a lot going on, but we don't have the mapper or the app or anything running, so we're going to install that just now. So I'm going to start by installing the mapper. And now I'm going to check. I don't have mirroring, so I have to kind of check that. Okay, our mapper has started. Then I am going to install the CRDs. I'm going to start with the model. No. And then the instance, which references that model. And now if I look at this device instance, we can find pretty much the same information I showed you earlier. We get the protocol, the config data, how to access the MQTT broker, etc. And we have an initial value of 0 raised hand in our device twin that you can see here. And now I am going to install the actual app that will do the hand detection. This one. And that thing should light up blue, hopefully. Yeah, it's blue. Yeah, nice. Okay, so I just need to port forward Grafana real quick. Yeah. And I need to bring Grafana to this screen. Apparently someone's raising his hand? No. All right, so it's a bit finicky, like we've not proven this thing to work 100% with audience. Joe, shoulder line. Higher.
I was trained.
So it's kind of like we always have to fiddle with like the camera placement and stuff. So can we get something going here?
Your shoulders maybe try my. I don't have broad enough shoulders.
Yeah.
So
okay. Antonia, do you like Kubernetes?
That's a yes or no question. How many?
It's a yes.
Yes.
Like who likes
Kubernetes? Okay,
Kubernetes?
this is a binary. Okay. It's.
Okay, I might be moving a little bit. So, okay, I'm going to try and leave it there.
I mean, it's
okay,
kind,
try and
it's
leave
kind
it
of
there,
working,
and you can see.
So.
So feel free to raise your hands as you want. You're gonna have to go a bit higher. Well, yeah. Now let's take a quick look at what it looks like. So here I'm going to bring up a couple windows here. So at the top left we have the actual device twin, which is a Kubernetes resource, so whatever is registered by KubeEdge in the Kubernetes API. So it goes to red when it changes value. And the top right is the MQTT mapper, the MQTT broker, so we subscribe to the topic directly. So instant feedback from the app. At the bottom, we have the logs from the MQTT mapper. So whenever we have a change, you can see that there is a slight delay between the KubeEdge CR and the actual MQTT publishing. This is because of like this kind of edge call, dance, everything that goes back to the Kubernetes API. So it's actually picking up a few raised hands now and again. Like our camera is not Army grade, so it's kind of, Amazon grade camera. So apologies for that. But we do have values that change on screen. You can see that it's not recorded. For the sake of time, I'm going to move on a little bit and talk about the setup just now. So we can find the same 3-layer diagram that Antonia talked about earlier. So at the top, we have the cloud part, which is the CAN cluster running on my laptop, which represents your cloud, data center, on-premise Kubernetes cluster, where you would run the cloud core. We have the edge part, which is the Raspberry Pi, so basically KubeEdge. That's also where we run the mapper in our case. And at the bottom, the device is the Raspberry Pi and the USB webcam. So this is obviously a serial demo. In a real-world scenario, you would have like proper cameras that would use IP protocols like ONVIF, and the processing would be done directly in the mapper. Talking about mapper, so the way this thing works is that Python app, whenever it detects a raised hand, will publish a message to the MQTT broker. The mapper subscribes to said topic. When there is a new message, it will update the KubeEdge custom resource, the device twin, and it will export it on the metrics endpoint, which is created by Prometheus and exposed by Grafana, which is what you saw earlier with the big number changing. This is not great. This is what we do like for these things, just to have a big number change when we raise our hands. But in real life, like you would push to a time series database or publish to an IoT solution that would do the processing for us. So hang on, just changing this thing, yeah. So you can find that demo here. If you scan that QR code, you will have access to that Giant Swarm repo. You will find the MQTT mapper, you will find the Python app, the custom resources, and of course, instead of like counting hands, we have a customer, for instance, what they do is that they have like a camera on the production line and they detect holes in their paper, like they produce paper, and this is what they use like with an AI model to kind of check out quality of their production. And Antonia will see us off.
Oh, really? Okay, yeah, thanks. Thank you for joining. Thank you for raising your little hands. It was really beautiful. You made us very happy. That's it.